feature, and then
Great.
we can get going. Great. All right, so I'm going to let the students in and we can get started. Hello, welcome everyone. Today is going to be an exciting panel. We are going to talk about careers and what do careers look like in the quantum world. So come join in, make sure you're muted, and as always, put your questions on Discord. Okay, so a few more minutes to join us.
Yes, fantastic, everyone. Joining on a Saturday after a busy quantum week in which you have finished Q Bronze or still doing it, learned about trapped ion quantum computing, had a virtual lab tour by MNT. It has been an inspiring week, and I hope we can continue that inspiring week today with more about careers in quantum.
Fantastic. Great. Well, why don't we get started? Thank you everyone for joining us today. Today is going to be a fun Saturday session. As you've been through the last 2 weeks of understanding the quantum world, understanding the industry, understanding quantum programming, understanding the fundamental physics, you are probably asking the question, what next? So here to answer that for you is an amazing panel we've put together. Actually, Christopher Bishop has put together. And Christopher Bishop is a man that needs no introduction. In fact, he has already been introduced to you by Celia, who spoke on Thursday when she mentioned the Quantum Economic Development Corporation and the quantum workforce as well. And she has mentioned Chris's name. So Chris is a technology futurist. He's a LinkedIn instructor. He talks frequently on TED programs. He's a former IBMer. And in fact, if you've ever been to any quantum conference, you're bound to run into Chris. So make sure you say hello to him the next time you see him. Chris also runs a fantastic podcast called the Quantum TED Podcast, and he has amazing guests come and speak on this podcast. And today he's going to kick off the panel, again, asking the question of what do careers in the quantum field look like? So Chris, over to you, and looking forward to the panel.
Well, great. Well, thank you, Prachi. Thanks to you and the team for inviting me to be part of this special event. Delighted you're all watching and listening. We have a fantastic panel. We're going to get into a really interesting conversation, I'm sure, about who the quantum industry is looking for. I want to quickly mention the names of our panelists and then ask them to briefly introduce themselves, give you a sense of what they do, where they work, what their organization does, so you have context for their answers to a bunch of questions that we put together to have them field, right? So to give you a sense of the run of how this, have our panelists introduce themselves. I have a very brief presentation that I want to share with all of you just to orient you to big picture meta perspective on quantum industry and jobs and careers and skills, right? Which I think you'll find interesting, hopefully exciting. And then we're going to field a bunch of questions and then end with sort of words of wisdom from each of the panelists. So let's start. In no particular order, the people on the panel are Richard Murray, who's the co-founder and CEO of ORCA Computing, Gabby Mize, who's a program manager at the coding school for the Qubit by Qubit K-12 initiative. She just finished a summer camp that I'm hoping she'll share a little bit of information about with us. Tina Brower-Thomas, she's the Howard University principal investigator at the Center for Integrated Quantum Materials, the Center for Quantum Networks, and the Co-Design Center for Quantum Advantage. And Chloé Archambault, who's the Director of Business Development for Quantum at Sherbrooke Quantique. So if each of you could just say a few words about your organization and what you do. Let's begin with Richard, please. Tell us about ORCA.
Thanks, Chris. Nice to meet everyone. I'm Richard Murray. I'm CEO and co-founder of a company called ORCA Computing. So we're based in West London, but all over the place in the US and in Canada as well. We build primarily photonic-based quantum computing systems. So we build quantum computers based on single photons. But also we have a large software and algorithm team that spends a lot of our time trying to apply those systems to mostly machine learning. So we have a very interesting and exciting sort of short-term program. If you're aware of quantum, you'll know that short applications for quantum computers in the short term are rather heavily debated. It's not clear what they might be. So there's a lot of creativity in that space. And then we also have a team looking at new error correction algorithms and error correction codes for photonic-based quantum computing systems. So that's pretty much it. We're a team of about 30 people and growing quite quickly. Thank you.
Great. Thank you, Richard. Gabby, tell us about Qubit by Qubit and the K through 12 and the Girls Summer Camp.
Yeah, absolutely. Hi, everyone. I'm so excited to be here. Like Chris mentioned, I'm the K-12 program manager of Qubit by Qubit. So we're part of a really awesome nonprofit called the Coding School, and we've taught about 20,000 students quantum computing since 2020. Our most popular initiatives include our year-long quantum computing course that we offer for high school students for credit. We work with IBM to offer that program. Really excitingly, this summer, we have a lot of initiatives starting, including our all-girls quantum computing camp, which is funded through a National Science Foundation Award in collaboration with the University of Arizona. We've also placed over 24 of our alumni of our year-long course with local research opportunities at their kind of nearby universities. And then for our undergraduates, we've also launched a program called the Early Quantum Career Immersion. So we've worked with IBM, Google, QNECT, Unitary Fund, and BP to place undergraduate students who are just getting started in quantum after a 5-week training with us and a 5-week internship with their industry placement too. So lots of exciting programs happening and really excited to be here as well.
Great. Thank you for sharing that. Tina, tell us about your work at Howard and the other amazing places where you contribute.
Yes, thank you. So I'm with the Center for Integrated Quantum Materials. I'm a materials chemist, and at Howard, I'm the executive director and PI. But the center overall, I am the education director. But I also have worked with the Center for Quantum Networks and the Co-Design Center for Quantum Advantage. But InSequum is an NSF-funded science and technology center. It partners Harvard, Howard, and MIT and the Museum of Science Boston. It also has a college network, which includes in the DC area, Gallaudet University and Prince George's Community College. Gallaudet is the deaf of hard and hearing college. And in Boston area, it's Wellesley, Mount Holyoke, and Bunker Hill Community College. And our center brings together outstanding investigators to push the frontiers of quantum sensors, quantum communication, and quantum computation. I support the area of 2D quantum materials. The center, as an education director, I implement strategies to attract and retain young people in STEM, particularly those who are underrepresented. And central to that is really building a community that is inclusive, excited about the work that they're doing, dynamic, and responsive. We attract a diverse group for our summer school. We have a 10-week summer school. We have an academic year internship. We have various seminars and workshops that give our students opportunities to talk to the community broadly about quantum. And we just, we're really in there. We're in the weeds and we enjoy it.
Great. Great work. Thank you, Tina. And Chloé, we met when you were at Anyon, so you've made a transition. Tell us about Sherbrooke Quantique and what's going on up there.
So I have made a switch. So Sherbrooke Quantique is an organization based in Sherbrooke, Quebec, Canada, which goal is to help build the quantum ecosystem and to build a quantum industry in Quebec, Canada. So that means a lot of things. It means bringing all of the actors together for people to interact, to events, to any opportunity they have, and we hope that will generate applications. It also means putting together all of the different pieces of the puzzle to help quantum companies grow and become successful. So essentially, I work on setting up different programs. It can be incubator programs for startups. It can be providing capital for startups. It's also related to finding office space, lab space, equipment, anything I would say that can help our startups and create this ecosystem. Somehow, Sherbrooke Quantique is probably involved in it.
Great. And again, a lot of quantum going on in Canada. I don't know if viewers are aware, but there's a lot of focus, a lot of funding from the government. Waterloo has terrific programs. So thank you all. I have a few slides I want to share, if you'll indulge me. Just to, again, set the tone. Let me start this deck. Bear with me. Go to slide share so you can see this. And then we'll get into the questions. So here we go. All right, can everybody see that? Is it working? Is it painting? Is it visible?
Yes, we can see
Yeah.
it.
Okay, good. So again, I want to do this quickly, but again, I want to sort of frame the conversation here. So this is a quote from Bob Souter, whom many of you know. If you don't know him, you should definitely follow him on LinkedIn. He was at IBM for many years. He was one of the first sort of quantum evangelists, if you will. But his comment is, whoops, hang on, basically that quantum is happening, in a range of industries. It's not limited to one setting. So it's, banking, capital markets, insurance, automotive, aerospace, and energy. And obviously, the industries that are leveraging quantum is going to continue to grow, which translates to careers and roles for all of you watching and listening. I think it's good to mention quantum supremacy. It's a bit of a point of contention, if you will, certainly between IBM and Google, but worth mentioning for those of you who may or may not know this, that in 2019, Google's Sycamore quantum computer performed a calculation in 200 seconds that a classical computer would have required 10,000 years to complete. So worth noting, anywhere where you're capturing and rationalizing data, this has tremendous implications. I'm going to share some examples with you, but quantum supremacy may be realistically many years off, if not decades away, but quantum advantage, which is a more near-term benefit, I think is achievable, and there are already case studies and use cases, examples of how this is being applied in the real world. So just wanted to note that. You divide problems into two categories: ones we solve every day, they're challenging, but we can solve them. Then problems that are so hard we don't even really think about how we might solve them. So some examples include around logistics, right? Optimization. There's just traveling salesman problem was introduced in 1930, and you can see that the numbers when you determine how many cities you want to visit efficiently. So 15 cities is in the billions, 20 cities, adding 5 cities to this equation puts it in the quadrillion range, right? Imagine implications for manufacturing. Drug discovery, so modeling complex molecules, classical systems kind of run out of steam at a certain point, but with a quantum solution, you could, in theory, develop cures for cancer, genetic diseases, Alzheimer's, the next pandemic that we're going to be dealing with. In finance, there's a lot of focus. There are companies, not to plug any specific organizations, but Multiverse and Terra Quantum are doing very laser-focused quantum applications in financial services around portfolio optimization, complex Monte Carlo simulation, investment strategies. There's a desk at Goldman Sachs, right, that a gentleman named Will Zhang runs. And so this is getting a lot of focus as well. Networks, a lot of work going on. This is from the University of Chicago, Chicago Quantum Exchange that David Ashalam is leading. There's efforts in the Netherlands and in China, but the idea of putting together a secure quantum network has implications for anyone looking to send data in an immutable way, right? Finance, healthcare, legal, military for sure. And then this is one of my favorites, predicting the weather. So we can predict the weather, with probably 85% accuracy over, 3 to 5 days, maybe 60% accuracy over like 10 days. Imagine if you could predict the weather accurately for 100 years. So certainly there are a lot of stochastic variables that would make this challenging, but in theory, implications around weather, impact agriculture, transportation, education, environment, logistics, manufacturing. Imagine if LL Bean, who makes outdoor gear, says to their supplier, it's going to be a really cold winter in 2039. Could you please make more sweaters? We need to ship them to Nebraska, by January 15th. So anyway, phantasmagoric for sure, but just to give you a sense of it. So, how can today's learners or workers contribute? So lots of different ways. This is a chart that I put together that I call the evolving quantum workforce ecosystem, right? And again, I won't belabor it. I'll share these charts with Prachi and team so they can distribute them as needed. But the idea is certainly there are scientists at the core of quantum businesses, business models, but like any burgeoning business, there's skills required across a range of disciplines. Sales, upper right, biz dev, companies of varying sizes. IBM, 420,000 employees down to Cole Quanta that has like 130. So everyone's trying to generate, business, attributable revenue, UX design, education, regulatory and policy conversations. I'm sure Celia Merzbacher talked about that earlier. optics, wiring, photonics, the sort of picks and shovels, if you will. I spoke to a guy at Vescent who was saying that the woman who runs his test bench is the most valuable employee in his quantum company. Just saying. Comms and PR, marketing and branding, investing, as I mentioned, Goldman has a desk, strategy consulting. So the idea is, keep in mind, there's lots of opportunity for you, listeners, watchers, viewers, to get involved in quantum. We're going to talk about that. This is just a point in time view of by no means comprehensive, but to give you a sense of the number of organizations that are working in the quantum information science space. Again, that translates to opportunities for people to have careers and jobs and do interesting work, right? So anyway, we'll see you in the quantum-enabled future. I hope that gives you a sense of what we're going to talk about today, right? So let's begin. I want to start with Richard. Let me doing my toggle here to get to my questions. So Richard, as based on the fact that you're running a leading quantum computing company, what would you say are your top needs in terms of quantum talented employees?
Really good question. I suppose in a minute I'll pick up on the need for diversity. But in your chart there, you showed the nice thing in the middle. QIS talent. So the company, as I mentioned in my introduction, is now 30 people, growing to 60. Most of those people are PhDs in quantum, and in our case, sort of photonic quantum. So people who, in their PhDs, have learned how to make single photons, who've been in a lab and have built this system. That's sort of pretty straight answer. Most people would probably say the same. I think what's interesting now is as the company grows, more in the periphery of your diagram, you had all of those other talents. And so I think these roles are more challenging. So what I mean are people, so for example, let's take salesperson. So you might think, salespeople are all the same. In fact, finding a salesperson who is okay at communicating what quantum is and the benefits of it, so who knows enough about the technology that they can convey that, but at the same time is able to articulate themselves and communicate well, it's really hard. It's very hard to find someone in both of those two worlds. And similarly, you might pick anything else, sort of marketing, same sort of set of skills. I would say also in particular engineering. So ORCA is starting to build products, which means we have things that we've done in the lab, and we now need to translate those into products which we can ship to customers. Those might be across the world, and engineer those systems so that they work, so that we don't have to worry about also shipping a PhD student with our devices to sort of fix it once it arrives at the other end. But we can just design the thing so that it's robust against temperature variations and NOx and other things like this. And again, it's really hard because those people can never quite depart from all the quantum stuff we're doing. So they have to be, either they have to have the background in quantum and also engineering, or they need to be sort of creative and intelligent and adaptable enough to pick up all of this stuff, and maybe even sometimes say, I don't really need to know about any of that stuff. Just tell me the stuff I need to work with. So I'd probably pick those peripheral talents as some of the most challenging recruitment needs that we have. Yeah.
Yeah. So Chloé, and from your experience at Anyon and now at Sherbrooke, what about your take on that? What are you seeing from where you sit?
I could talk from previous expertise. So as you mentioned, Christopher, I used to work for Agent Systems, which is a company building quantum computers. So similar to what Richard said, we needed, of course, quantum scientists and physicists, and they are pretty hard to recruit because there's some scarcity there. But physicists were only a small part of the team. There were many different skills that were needed. So we needed mechanical engineers, electrical engineers, software developers, industrial designers, and many other skills, which I'm not going to name. You had many on your slide. Maybe one thing that I would highlight is what was the most important in many cases when recruiting was not necessarily the degree, but more the mindset of the people, the person we were recruiting. In many cases, we saw people coming from academia. There had to be some transition from the academic mindset to more of an industrial mindset. So doing research in a university is not the same thing as developing products in a company. You have to change the mindset. and also work on what I would call professional skills, which most purely scientific programs don't necessarily teach to students. So things like project management, teamwork, documentation, and many of these skills, which are very important in the company. And when I say documentation, it's not about having a lab book. That's not the same thing. It's about documenting your work so that anybody else in the company can, if you're sick, one day anybody else in the company can pick up your work. So that's something different. So many of these skills, I think, are very valuable.
Yeah, great. No, thank you for mentioning that. So I want to shift gears to go sort of supply side and get a sense from Gabby, certainly, as a leading quantum training organization, Qubit by Qubit, what kinds of guidance or feedback are you getting from, say, organizations who are looking for quantum talent? You said you placed like 2,000 alumni. Obviously, private sector, government, national labs are, where people go to work in this space. Are there students coming to you with requests, say, for a specific quantum training based on interaction with the job marketplace?
Yeah, great question, Chris. I think that it's pretty nuanced right now, kind of like Richard was mentioning, and Chris, even in your slides, there's so many different ways for students to enter the kind of quantum workforce. What we've been really focusing on so far, and like with my role in the K-12 part, is that we know when we have many of these applications kind of coming to fruition in the next 5 to 10 years, we'll need folks with, bachelor's degrees. And currently a lot of, at least the jobs I've been seeing and jobs that I've been, consulting with do require like physics PhDs or QISE PhDs as they're kind of coming to fruition. And one thing that I'm excited about is that we have been kind of training all of these students from all different backgrounds in quantum computing more generally. In the most near term, I've seen a lot of interest in like quantum software engineering. So we teach students Qiskit and Python, a lot of quantum-based libraries, so that whenever the kind of workforce is ready for them in its current state, that our students are prepared with kind of some of the key skills. But I would also say that one thing that we're doing is we're trying to broaden awareness just generally about quantum. And so we have students around the world who don't necessarily want to go on and become quantum physicists or kind of interface with quantum computers directly, but they're really bringing that like quantum literacy to whatever positions that they're interested in. So for example, we had at our all girls computing camp, we had one student who just really, really, really wants to be a journalist, and she is going into her junior year of high school. And she's like, well, now I know how to talk about quantum and just explain it to my parents, explain it to my teachers. And I think that is also a huge benefit. And kind of like Richard was saying, it's really, really hard to find someone who's able to translate the kind of scariness of quantum into something that the general public understand. And so I also see huge utility in Qubit by Qubit, just generally introducing the general public, because we have students who may never have considered themselves a quantum scientist, really getting excited about this field and knowing that it can be an option for them in the future. But we also, we like to leave things open. And one thing that we've seen is that through taking our courses and our programs, that 96% of our students feel more confident in their STEM skills. And so I think that quantum computing just generally is a fantastic way to like reinvigorate younger students and get them excited about STEM and kind of see the specific areas that they might be impacted by quantum as well.
Great. Thank you for sharing it. Tina, in your role, you work with quite prestigious universities. Harvard, MIT, Howard. Are you getting feedback from industry or from private sector or other, potential employers of quantum students about what they, would like to see them learning or skills they might need to have?
Yeah, the feedback that we're getting is still at the area of being quantum aware. So being really solid in whatever their field that they've studied, so that they can be adaptable, because there's still, you mentioned so many companies. What we didn't say is that some of these companies that are into quantum research, they have different platforms that they believe in, right? So you can't necessarily focus on one particular area from the undergraduate level. You have to be nimble. And so I think what industry is saying is prepare, really good students that are adaptable. And they also need some skill sets that, may not be the PhD. So we need technicians and things and quality control. So those types of jobs are still very important for industry. And so there's a broad range of opportunities for undergraduates if they don't want to go into a master's or a PhD program. But I think we're still at the point where universities are just setting up certificate programs and master's programs. That's still a small community. So not everyone is going to have the opportunity to learn quantum, you know, in a formalized way and have a formalized degree or certificate behind their name. But they can all study really well physics. They can learn optics. They can and become quantum aware and delve into other resources out there that sort of marry or the training that they've had in undergrad.
Yeah, a question that this is brought to my mind around the degree to which people can work in quantum with skills that they bring that are transferable, and then where there's some white space, right? So. And Richard, I want to ask you that. I want to get each of you to share your perspective. I mean, the reason this sort of came to mind is hearing you talk about, the range of skills, certainly, and the range of disciplines. But I was at an event at Form Factor recently up in Boulder, at the QED-C plenary, not bragging, just telling you what goes on in my life. And I sat next to a woman who I said, how'd you end up working at Form Factor? She said, well, I said, what's your training? She said, well, I have a degree in accounting. And I'm like, really? She said, yeah, but a friend of mine mentioned that Form Factor was looking for people to, deal with metrology on a laser, on an optical bench or whatever. She said, so I applied and they hired me. She said, I've been here 3 years and it's fantastic. And the message is they trained her to do what they needed her to do. And I think the advantage was she didn't bring any baggage about, oh, well, this is how I did it back at company X, and this is the right way to do it. And it's like, she was sort of a blank slate, if you will. So they trained her. So Richard, what's your take on how much of that goes on, given the rate and pace at which quantum is exploding, right? I mean, growing.
Yeah. Well, a really awesome question, because I actually want to answer just to say that I think the main problem with quantum at the moment is you've got a load of people who have spent the last 20 years working together. So a lot of quantum activity, a lot of the people who build quantum computers, they haven't had to speak to anyone else for the last 20 years. It's been let's be honest, it's been a really academic subject. And that's not scalable. That's, to my point about building products, quantum needs to be sort of welcoming, and well, not welcoming people, it needs people with those outside skills, maybe because they don't have the baggage and they can think more creatively. Maybe it's because there are skills like scaling up and manufacturing that hasn't existed and been needed so far, and marketing and things like this. So it is absolutely critical. I think one of the challenges, though, which is important and shouldn't be sort of not discussed, is if you are someone from the outsider, and by the way, I'm an outsider. I had a PhD in quantum and then I worked as a consultant and all sorts of other things for a long time. Wow. As an outsider joining the field, you will be faced with people who have only spoken to each other for 20 years. And I think one of the main challenges for those outside people is not to be perturbed by that. And the people we look for are the ones who are like, don't tell me any of that. I don't need to know about superposition. I just want to know, like, what are your input-output requirements? Who are maybe it's a sort of combination of intelligence and creativity and sort of confidence to just sort of say, don't tell me that. I don't need to know that. If you put it in this framework, I can then work with you. But I mean, huge. And maybe the last point I'll make is just, obviously, if you look at some of the Boston Consulting Group's reports on quantum, the quantum bit is a tiny proportion of the future market. Right. So, and the rest comes through marketing, and it comes through products and services and software built from quantum. So this is a huge sort of supply chain of skills that we're talking about now, not just people who can build qubits.
Tina, you had your hand up.
I just wanted to add that another component is strategic partnerships between industry and academia. So we often have industry workers that we offer training and workshopping so that they can understand, take the skill sets that they already have and add, the concepts behind quantum, whether that's materials and networking and algorithms. And so I think we need more of that, those strategic partnerships between industry and academia, and to some extent government labs as well. I think
Yeah.
that's important.
And so, and to follow on that thread, my next question was around, so what could industry or business, really private sector, do to improve, quantum workforce sort of availability, if you will? And Chloé, I want to ask you, because again, you have made this move from Anyon to your new role. What's your take on that? Like,
Well,
what could business do?
I think business have to remain open. I'm going to totally agree with what Richard said. The community has been pretty closed in the past years, but it has to open up now. And it's already doing that, in my opinion, because essentially the quantum industry is a nascent industry, right? We're building the plane on the tarmac. So we need to build the workforce in parallel. If otherwise, there won't be anyone to take these jobs. If we were only to hire people who've been doing quantum computing for the past 10 years, we wouldn't have any people to hire, because this small community, they already have jobs, right? So very important to take people from different fields. And it's also important, since it has been a closed community, bringing in people from different fields actually opens up the perspectives. Otherwise, we might just miss out on things happening in different fields. And one thing that I think is particularly important is having people from the application domain and from classical technology. So we keep saying how quantum technologies have so much potential of doing things faster, better, etc. If all the people that say that are just physicists who all they have been exposed to is quantum, it doesn't have any perspective. We need to hire also the people who have been doing classical communication and classical HPC, high performance computing for the past years, so that they really tell us, is what we're doing really better, or how can we improve to make it better, or how can we be inspired in quantum from what they're already doing with classical technology, which is working great, probably.
Yeah.
That's
so
my message.
So that's sort of a business perspective. What about from I want to hear from Gabby and then Tina around, from the supply side, if you will, like what kind of programs, what's your sort of next dream program initiative around quantum training, Gabby, for Qubit by Qubit, like where to fill a gap that you see in the marketplace, an opportunity to provide talent for this nascent industry?
Yeah, we've actually, we're pretty innovative at Qubit by Qubit. So I'll speak to our early quantum career immersion program, which we really saw as filling a crucial need in this space. So that we've taken about 24 undergraduate students in this first pilot year who have computer science training, and then we've placed them in essentially quantum software engineering internships after a kind of quantum boot camp, if you will. And so I think that will certainly, what we're being told now is that, there will be jobs. There's going to be, I think Accenture released a report that there would be 100,000 jobs by 2030 in New York City alone in a quantum related field, right? And so if we're seeing that, what our students need to have is to have experience to be eligible for those positions. And so we know that there's, quantum internships out there, but there's not much at this point, like interfacing with industry and kind of like the growing or future workforce. And so this early quantum career immersion program really rose out of, having lots of, excited students who are interested in quantum or interested in QED-C more generally, and then being actually able to place them and say, like, here are not only like the business and professional skills that you need for an internship, but also the really critical skills that we're being told from an industry side that they're sorely lacking and have had difficulty recruiting students within. The other huge part of that is also we need to have a diverse and inclusive and equitable future workforce. And so we need to make sure that students of all backgrounds, but especially those who are traditionally underrepresented and minoritized in STEM especially, are given access to these opportunities at the same rate that other students have. So that means, working with colleges that perhaps aren't, kind of the big names in quantum, but there are really awesome students all over the world at community colleges and other institutions that haven't had the quantum resources so far. And so we need to make sure that we're also equitably distributing the education as well, is kind of our most critical, I think, need at this moment.
Yeah.
Tina.
And Tina, based on where you see, so major universities, like how are they responding to curriculum needs, or, driven by industry or national labs?
Well,
or government?
I want to go back to like what I do, the dream thing, if you don't mind, because in the center I work with, I mentioned we have a college network. So we have for 9 years partnered with Deaf of Hard of Hearing University, 2 community colleges, and women's colleges. Strategic partnerships are essential. You have to really think about who are you working with. If you start with that, then it's built in, the diversity is built in, and that's been my experience. We've had, I don't necessarily go after thousands and thousands. I go after hundreds, and those hundreds have strategic partnerships. They have a community that needs to be broadened. So we also partner with a very influential, I'll say, a high school that has a lot of resources in the Boston area. And we partner with other high schools that don't so much have those resources. In the time of COVID, we had the opportunity to see what we could do virtually. So I think partnerships with sort of disadvantaged school systems with those that are more advantaged, sharing those resources remotely is essential. And I think if we did more of that on a broader scale in sort of pockets of communities around the country, we could go very far in building the future workforce. So I just go back to, there are top universities, absolutely, U Chicago, Harvard, MIT, that have quantum programs. I don't like to list because I don't like to leave people out. There's other institutions as well. And that's very important. But these institutions, I think it would be really awesome if they figured out ways, and I think Qubit by Qubit is doing some of this, where you're partnering those who have a lot of resources that have, whether that's funding, whether that's the top researchers that they understand and are committed to partnering with those who are not, that do not have the same resources. If we did more of that, then our problem is solved. And it's a problem that is, really rooted in our educational system in general, which is, we know in the United States it's not an even playing field. So this is a new technology. Well, it's not a new technology. I shouldn't have said. Anyway, my brain corrects myself as I go. So I have to be careful and just stick to what the main point. It's a
newly applied technology.
Thank you. A newly applied technology. We don't want another digital divide, right? So we need to we already know what could happen if we're not, proactive about it. So let's just do it.
Yeah. So Richard, I want to just sort of continue on that theme. I mean, certainly gender parity is a huge area of focus in every business, and definitely in technology, and now more broadly, diversity, equity, and inclusion. Again, being, at a major quantum computing company, what's your take on how this might be addressed?
Well, it's hard. It's really hard. I think the first step is, and this is sort of a bit of a cop-out, but the first step is for everyone to recognize how bad the situation is. I think there aren't many other industries where, 95% of the workforce, I don't know the actual numbers, but let's be honest, it's a very high percentage of the workforce just looks exactly the same. And I think that's bad for the industry. I think all of the creativity that I mentioned, the first starting point is to recognize how bad the situation is. But at ORCA, I think one of the things we really strive for, again, hard with the workforce that we've got, is to try and judge people on the basis of potential, not on past achievement. And that's hard because, it's very easy to look at someone's academic track record and say this person has X number of publications, has worked in this group, and that therefore makes them a very good fit. In one particular way, it's harder to say, okay, let's assess this person's potential. Let's run some sort of tests and competency tests to see whether they could be sort of excellent in the role without having that track record, which they might not have had if they hadn't had the privilege of sort of having a particular background. But I think actually there's a huge benefit in doing it that way, because, the person with the long track record is really, really good at one thing. And it's important. I always remind my team that person has been proven in doing that one thing. Well, what happens if we end up doing something different? What happens if are they going to notice a completely, unique, creative idea that came out of sort of left field, I think they're not likely to spot that as someone who has potential and sort of maybe is sort of more creative in their outlook to things. So I think that's my approach. It's not the great. I think internally we try and strive to look for potential. I mean, in terms of formal things, events like this are of course incredibly important. ORCA runs a number of hackathons, and those are open to everyone. We ran one really cool hackathon event in London, attracting individuals, in fact A-level students, so sort of what's that in US, from lots of sort of lower socio-economic schools from around the area. I think everyone's doing that type of thing, and I think it just needs to ramp up and continue to sort of meet the needs of the industry. But I would say it's one of the things that worries probably me the most, and probably a number of other quantum leaders, is this diversity sort of issue, but also maps directly onto sort of creativity or sort of diverse outlook type problem as well. I hope that answers your question.
A great point. I mean, you're recognizing that is a problem, so we can focus on it. I mean, I think that's key. I wanted to talk about resources. So just give each of you a moment to guide our listeners or viewers. Like, are there one or two resources that you would point them to find opportunities in quantum, right? Like, and be specific if you can. I put together actually a sheet for the QED-C that lists career pages at like 60 or so quantum companies. But I wonder if you have other resources you could point people to, like if you based on, say, what you know or what you're interested in, where might they go? I mean, maybe not Indeed or Monster or Upwork, but certainly maybe LinkedIn. So Chloe, why don't you start? Give us your sense, because you're training people that are then going out looking to land somewhere, right? So,
well, I can talk for the Quebec ecosystem. There's a group called the Quebec Quantique. So if you go on their website, they also have a list of all the quantum jobs in the province, and I think in Canada as well. So that's one place for jobs. And maybe one resource, not about jobs, but the resource I would point to for people who are curious and just want to get up to speed, I would say, on quantum without necessarily having to become an expert. My go-to place is the Quantum Computing Report. So it's an online site, and it's going to teach you all the basics you need to start talking quantum.
Yeah, that's great. Yeah, Doug Fink, by the way, is the managing director. That's a great resource. Yeah. Gabby, what about you?
Yeah, not to shamelessly plug all of our programs at Qubit, but I am very, very proud of the curriculum that we put together. So if we have like any early learners or transitioning learners into the field of quantum, I would definitely recommend checking out our website. And if you're looking for just like more general news in a digestible manner, I've really enjoyed Quantum Magazine, and then of course like physics.org, and there are some Scientific American. It seems like every other day there's a new quantum related article or new thing that has come out recently, and I've so far trusted the writers there, and I think that they've been able to put it out in a very digestible manner.
Great. Tina, what about you? Where would you point?
Yeah, so of course I'm more on the academic side, and not that I force people into graduate school, but I'm very proud of the fact that we, 84% of the young people that I've worked with have gone on to either master's or PhD programs. So I am partial. I would say since Kara shamelessly plugged, I'm the shamelessly plugged Sequum. I'm sorry, Gabby. I'm going to shamelessly plug Sequum's website. We also have some curriculum there. And I think professional societies are very important, particularly IEE, APS, MRS. I think also Nano Hub is still a very good resource. And key concepts for future QIS learners is what NSF put out. I think that is a great resource to go to and get those terms that people say are scary, like quantum entanglement or superposition. Just knowing what the key concepts are and doing your own research on it, I think is valuable.
Great. And Richard, other than the career page on the ORCA website, where would you?
Yeah, I'll resist. Yeah, great answers. And actually, the previous answers have been so good. I'll throw in something slightly different and maybe a little philosophical. There is one huge resource to everyone, and that's sort of to look inwards. And maybe I'll mention your own initiative and ambition. And I'll say this only because the few answers have been so good and covered off everything else that you can rely on. I want to highlight how many sort of CVs or approaches I get from, and I'll be honest, sort of white 30-year-old PhD guys. So, and I want to highlight I think it's sort of the hidden secret maybe, that one of the things you can do that ends up being quite successful is pick the company you want to work for. Think to yourself about, how good you're going to be if you get a job there, and walk up to the CEO at a conference and say, I think you want to recruit me, like, here's why. And that is the type of confidence that obviously I think is held by certain sort of people, maybe rightly, but it should be held more widely by people who are really excellent. So on top of what everyone else said, like, do sort of check careers panels and things, but don't forget the fact you can just email. We're all human, people who run these companies. We're all on the lookout for great talent, and we're all on the lookout for really ambitious, confident folk. So, like, if you can get outside your comfort zone and just go up to the CEO and say, I think you should give me a job and here's why, I think you would get a lot of respect for that.
Yeah, great.
But that's a bit of a left field answer.
No, that's great. Thank you. So we have some questions in the chat. I want to pull some of them up so we can get your expert perspective. So here's a question. Is it possible to be hired while doing a PhD? How do we gain work skills while in academia? Someone want to field that? Tina, maybe, is that something you could respond to?
I would say, honestly, it's probably a little difficult to get hired while doing a PhD. Maybe in a startup company that started out of an academic institution. You might find doing work there, supporting a startup is a possibility. It's not that easy. One of the greatest challenges I've had in my center is actually getting industry jobs for graduate students and postdocs, like industry internships. Because to some degree, what Richard mentioned is that when you're in academia, you are very narrowly focused. And if it's not a true match with the industry, then they may not, necessarily want to spend the resources on someone who's going to be very narrowly focused. So I think, with that said, I think it's the best thing to do is try to have a broad range of things that you understand in quantum, and still having your specific area that you're the expert in. But the more diverse you are in terms of your understanding of quantum and quantum applications, I think the more likely you are to have that. So I hope that answered the question. But
that's great advice.
It's not easy. Yeah,
it's not easy. Yeah. A question for Antonio. Oh, sorry, no, go ahead, Richard. We're going to sway in.
No, I'd add, if it's possible, the longer you can spend with the company, the more advantageous it is for the company, if that makes sense. So, when a PhD student or whoever joins us, there's quite a lot of time we need to spend with them to sort of make their skills more industrial or familiarize themselves with the company. It's quite hard to justify that if that student's only going to be with us for 3 months and then they're going to go back to their PhD or do something else. If you can persuade your PhD provider or whoever that you want to have a year off, to really embed yourself within a company, that looks a lot more attractive to us because we know we can work with you for a whole year and you can really get up to speed. It's probably good for you, but of course it does mean delaying the completion of your PhD. So I just mentioned that the time that you have available, and obviously if you're really not able to I can give the company half a day every week, that type of thing is really hard because it's hard for us to imagine that you get embedded enough to do any useful work. So think about the time commitment, I'd say.
Yeah, no, great,
and of
great
course
insight.
The professor is going to want, they're like, you're on my grant. Like, you have a certain amount of time to get this work done. So if there's a synergy, then it could work. And so, yeah.
Yeah, no, great insight. Thank you both. Here's a question from Antonio Davis saying, do you think it is preferred to focus on hardware or software for quantum computing, or are industries more interested in people who have good backgrounds in both of them, but less focused? I think probably depends on where you're going to be, right? But maybe, Chloe, can you field that? What do you think?
So that's the kind of question I would simply answer to, like, go into what you're interested in. If you're interested in software, there will be a job for software people. If you're interested in hardware, there will be a job for hardware people. If you want to be more of a generalist and know a little bit about both, that's extremely valuable as well. So don't spend too much time asking yourself questions, just follow your heart.
Yeah, I think that's great. If anyone else want to weigh in on that, I think it's
Well said.
clear, right? Yeah, like pick what you are interested in and go for it, right? And it may morph and change, right? That's the other sort of thing I would add. I mean, you may join a company in a certain role doing a certain thing and discover that you like doing something else as well or better, or they may move you into a new role based on how you perform in the role they hired you to do. I mean, that's the exciting thing about sort of any business, but certainly about quantum, right? It's malleable. We're making it up as we go here. That's what makes it fun and interesting, right? Question from Abdullah Townsi in Algeria. What is the difference between industry mindset and academic mindset? What should a PhD quantum scientist be aware of when collaborating with people from outside of academia? So who wants to take that?
I jump in.
yeah, please, Richard. Yeah.
I was about to say night and day difference. Maybe it's not quite that stark. Because mostly because I don't want to scare you. We exist. Like academia exists to further knowledge, and companies exist to get that knowledge out there into products and then to make money. And that creates several very sort of big differences in how we need to operate to fulfill our primary objective. So actually, a lot of the ORCA team, people joining us, they still think that, they need to publish. As in academia, you survive through publishing. Sort of in industry, it's not important. I mean, it's a PR activity. You need to do it to show you're doing useful work, but only if it leads to useful product development. So I don't know. Maybe that's a sort of fundamental. Maybe that's not useful for the question you were trying to ask.
No,
I think the most
good.
important difference I would like. The more sort of significant thing is I think there is a big difference in the time that people can spend on problems. So maybe the most important difference to stress is how little time in industry you have to really delve into the depths of what a problem looks like. I mean, you're really looking for whatever you need to solve the problem and move on. Whereas in academia, you might have a lot more time to say, well, hang on a minute, I've solved the problem, but I still don't really understand it very well. In industry, we don't care. If you've solved it, you've solved it. But in academia, if you've solved it, but you don't understand why you've solved it, you'll spend a lot more time on that. So I suppose that's a sort of different perspective there.
No, thank you. Tina, you have your hand up. What do you think?
I just wanted to add to that. Some of the funding agencies and that the people who really give the money to, or they don't give it, you have to earn it, but they supply the resources for you to do research in academia. They're actually pushing more of the, what are you going to get at the end? Papers are great too, but so it's starting to have some overlap there. And I think, research groups that have people who are really good at writing the papers and doing the fundamental stuff, married with other folks in the group that can say, okay, what are we going to do with this product? I think are very successful. But I just want to sort of put it out there. If anyone who's in academia now going towards a degree, you kind of have to have both mindsets, because that's where the future in terms of how you're going to be funded, that's where they're going. They want people to tinker in the lab because, that's what you do in academia, but they want something at the end. So
yeah.
Beware.
Yeah. So here's a question from Rena Esmalati, asking, when I applied for internship positions this year, they all required some experience. Do you have any advice for us on how to gain this experience in advance and be a proper fit for these companies?
I'd love to know what point this individual, is this an undergrad? Is this?
Yeah, I don't know. It's not qualified in the question, but I think it's,
okay.
It's sort of a broad question, like how do you get experience if they're looking for people with experience and you don't have any experience? I mean, it's is it internships, or what would you say is the way in? I mean,
okay, I'll just go for an undergraduate level. It's I tend to look at rarely do you want to take a freshman, to be honest, or even sophomore, because I have to partner them with someone in academia that's coming up with a research project, and they really, they're looking forward to have input from the students. So sometimes the academic record is not there by the time they're freshman or sophomore. But there are sometimes, the folks like me who run internships will take a first year student and we'll find projects that make sense just to sort of get them along the road. And so I would say just look on your academic at different universities that do quantum, and look for a research experience for undergraduates and just apply. You never know. You can emphasize, what courses you're taking and really emphasize your passion and interest, and you might get picked up. For beyond that, if you are finishing your undergraduate degree and you haven't had experience in quantum, hopefully you've had some work experience, and I would just suggest, emphasizing your interest. And maybe even if you're writing like an application, tell the where you're applying the things that you're reading and what you understand and where you think that's going. And so you really just sell yourself, because this is a very new area. It's the opportunities are new, and so people on the other side are still trying to figure out to some extent what they're looking for. So sell yourself, I think, is the main thing.
Yeah, actually, that just got qualified. Oh yeah, Gabby, go ahead, please.
Yeah, I was going to add too, I think as we've all talked about, the quantum workforce is kind of building while we're on the tarmac. I think Chloe was the term that you used. And so one thing that I've seen a lot of our teaching assistants and our students do is actually there's so many adjacent fields that can be informed by quantum. So there are plenty of opportunities in software engineering and other sorts of internships that you can kind of gain a sort of experience alongside, your quantum informed studies potentially. And so I would also encourage students to kind of keep an open mind in terms of what they want to do. Because if ultimately quantum is a dream, I'm certain that we'll all get there. But sometimes it doesn't always follow a linear path, and that's okay. We have, folks joining us, and even currently, a lot of the folks, they didn't study, quantum computing or quantum information science back when they were in undergrad or in their PhD program, because it didn't exist yet. In many cases, the formal degree programs anyway. And so just, everything is constantly changing. And so I would just recommend to everyone to keep an open mind when exploring opportunities and kind of choosing their pathways too.
Great. Thank you. Chloe, yes, what's your take?
I can add also hackathons, I think, are a very great place to learn. It really gives you hands-on experience, and most of them are open to people even if they don't have any experience in the field.
Yeah, great. Thank you. So we're coming to the top of the hour. I have what I call words of wisdom I want to ask our panelists to share. So what advice would you give to people interested in working in quantum information science, maybe whether they're students or even mid-career? So let's go around the horn here. So Gabby, why don't you start, please?
Yeah, so actually I'm wearing our t-shirts from camp. So it actually says, I am a future quantum leader. So I just want to let everyone know that you've already started the first step. I know that we have several PhD students and folks that are kind of well familiar with the space, but I think that the first step is always, taking off and choosing opportunities such as this one to kind of empower yourself with your own kind of educational journey. So just want to give everyone kudos to that, and just know that I think that this field, more than any that I've ever encountered, are really excited about the folks that are incoming. And so just make sure that you're networking and creating that community of folks to lean on when exploring opportunities. And yeah, just you all are our future quantum leaders. So thanks for being here.
Great. Thank you. Chloe, what about you? Words of wisdom.
I would say that don't worry too much about your career. It's okay not to have a clear career track in mind. It's okay not to know exactly what you want to do. Just as I said before, just follow your heart. If this is what you want to try right now, go ahead. And if I can talk from my personal experience, my career was not a straight path. It was much more like a zigzag. But today I feel that I'm exactly where I was supposed to be. So it's just going to make sense in the end, and try things out. And there's no wrong choice, essentially. If you try something out and you don't like it, like from my perspective, it's always a good thing because you learn about yourself, you learn new skills, and you can always pivot.
Great.
You're not going to regret it.
Yes, great. I totally agree. Richard, what's your take? Words of wisdom.
Yeah, this is so hard because the previous answers are so good.
No, come on.
I would really say, I think it's really important to remember to be super, super confident. And what I mean, to unpick that a little bit, to be honest, I find if you are in academia, it's an environment which is hard to be very confident. You know, you're in amongst people, you know, it's a very challenging work you're doing. You're in amongst other people who are really highly intelligent. And I think it's really easy to forget how good you are. And I think anyone working in quantum or anyone sort of considering working in quantum, important to remember, frankly, how good you are and stay true to that and how much value you can bring to a company. And back to my point, believe me, there are other people who can be very, very confident without as much good reason for it than you.
Yes, great. Tina, what closing take?
Yes.
Words of wisdom.
So obviously I'm a double minority, and I have to speak directly to people who look like me and so forth. And I would say quantum is for you in a very practical sense. A lot of the research that's going on in quantum, your tax dollars are paying for it. So don't ever buy into the idea that you're not supposed to be in this space, because not only are you supposed to be in this space, but you're paying for this space. So have that as part of your mindset. It is for you. And also just hang on. Like you might get messages that say you don't belong or asking you why you're here. Ignore those and just hang on, follow your passion. And remember that I think in general, I said this to an audience yesterday, STEM is a language. Quantum is a language. This idea that it's spooky and weird, maybe, but actually it's a language. If you learn the language and you get past like the third or fourth thing, you ever filled out an application and the application seems really long? When you do quantum, anything in STEM, it's like you have to train yourself to do the application all the way to the end. So it's going to take longer. You're going to have to invest more time. You're going to have to dot your I's and cross your T's. But it's really like filling out a long application, hang in there, get to the end of the application and learn the language, and you will be fine.
Great, thank you. So we've come to the end. It's been a wonderful conversation. Thank you to Gabby and Chloe and Richard and Tina. I want to encourage all of the viewers, listeners, watchers, whatever, to connect with all of us on LinkedIn, right? Reach for us, at least follow us, send a connection request. I'm always happy to make new friends on LinkedIn. I also want to put in a plug for my initiative called Office Hours, which I run on behalf of the Quantum Economic Development Consortium. You can send a note to our task ID, which is officehours@quantumconsortium.org. We're running our next session on Thursday. It's a chance for students studying quantum information science to connect with mentors in the private sector and have a one-on-one conversation to learn about how to make the transition and how it works and what the benefits might be. So thank you to the Womanium Quantum team for inviting me in this distinguished panel. And
thank you, Chris, for putting it together. I'll just say few words, and then Chris, I can give the last words to you. Just a few things. I do have one last question, and a lot of students have asked. This is a question for Richard. Richard, where are you located? Because a lot of students want to walk up to you right now and walk up with you with confidence and tell them to give you a job. So, students are really excited, and everything that you all mentioned in terms of diversity and confidence. This is why we've created Womanium as well, because confidence comes from knowledge, from a certain understanding, and knowing you can apply it. And for this program as well, we have over 44% of participants that are women. So we're really excited to now having new people join and understand the quantum field. And actually 30% of the students are PhD students already. And this is, again, coming back to your point, we have very qualified people already in physics and optics. And how do you then introduce them to quantum so that they can make that pivot and enter the field? So thank you all for joining and sharing your best practices and examples of how do you make a mark and a dent in this field. And thank you, Chris, for putting together this amazing panel. Tina, great to have you here in DC. We should definitely meet. Chloe, thank you for sharing your experience as well. I think the project management and all the skills that are needed to create a whole ecosystem, that's incredibly important. Richard, I think everything you've said really resonated. A lot of students are are also curious as well of your journey and of coming from a PhD program, starting your company. And the participants who are on, Richard and his team will be there in the career fair as well. They've also provided an excellent hackathon for us to solve. And the hackathon, I think, comes back to the question: how do you demonstrate skills to your future prospective employers? Hackathons and problem solving and having a GitHub repository is definitely one of the ways of demonstrating competence. So, and of course, thank you, Gabby, from your side as well. Qubit by Qubit does amazing things. So looking forward to partnering more with you. And Chris, over to you for last words. But thank you so much for putting together an excellent panel and a great discussion this Saturday morning.
Well, so my sort of meta comment, and I do workshops at universities on this sort of future careers stuff, and I always admonish and hopefully excite and inspire kids by saying, you're going to do stuff that's going to look like magic to me. So get to it. I want to see some of it. Come on. There's lots of opportunity to do really interesting stuff in quantum information science. So let's get going.
On those words, thank you all for joining us today and have an excellent Saturday.
Thank you.
Thanks.
Thanks
Bye.
all.
Cool. Bye-bye.
For the ones who are still there, I would really encourage you to take full advantage of the program right now in 5 ways. First, technical skills you are gaining. Second, soft skills. There will be pitch training, CV training. Third, showing your skills in the hackathon. Fourth, networking with companies. 30 companies will be there on 2 career fairs combined. Fifth, maybe most important, networking together. We have so many great participants. We are all inspired by each other. Get in touch. If you see, hey, this is an interesting question, or this is an interesting person, interesting topic, send a message, arrange a call, join the Hangout on Discord. We have so much potential in our group, and our group is the future. Maybe more than the 30 companies we have at the career fair will come out of this program. We have 1,000 people. This can be 100 companies. So network together and leverage it.
Exactly. Make your teams for the hackathons, but beyond that as well, make your teams for future people that you'll work with to join companies together, to make companies together, to work on projects together. Absolutely. All great points, Marlo. And if any of the students, if you're still online, want to unmute yourself, ask any questions, please feel free to do that. We have a few minutes to our program where we can take some questions. Let me give you unmuting abilities as well. So now you should be able to unmute yourself if you'd like. And we have Crystal here. So if students have more questions.
Also ask them to start their videos when they ask questions.
Yes, just introduce yourself, start your video, and ask any questions you may have.
So ladies, I have to drop, but thank you very much for the opportunity. I had a great time. I think it was a great conversation. And anyone who's watching or listening, again, connect with me on LinkedIn, send me a note. I'm happy to continue this conversation. So see you in the future.